Hi everyone, I hope you're okay, and I really hope that the videos we keep uploading are helping you out. On this video guys, I'll be just focusing on carboxylic acid and everything that has to do with carboxylic acids. Okay, a carboxylic acid guys, it's an organic compound that has a general formula which says CnH2n with 2 oxygens, which simply means that the number of hydrogens has to be 2 times the number of carbons you have on your atom, and then you must have 2 oxygens. Are you together? The functional group for carboxylic acid is called a carboxyl ion, and it is always found at the terminal carbon. This is the structural formula of your functional group. The name is carboxyl. Can say carboxyl group or carboxyl ion. Eh? Are you together? Your suffix will always be oic acid. Are you together? Your suffix will always be oic acid. So if ever have a structure like this, excuse me. This is a carboxylic acid. Why? It has a double bond and an OH at the terminal carbon. Since my longest chain only has one carbon, my prefix will simply be methane. And then I just need to insert the suffix. It's methanoic acid. Are we together? If ever I have something that has probably 3 carbons, since I have 3 carbons, my prefix will be propane. Are you together? The prefix will simply be propane, and then all I have to do is to just join the suffix. It will be propanoic acid. Are you together? That's how guys you name your carboxylic acids. Are you together? Sometimes you are given structural formula, condensed structures of your carboxylic acids. All you have to do is to convert them into structural formulas and then write down the IUPAC name. Sometimes you are given something like CH3, CH2, CH2, and COOH. This thing can be written like this, né? Or the same compound can be written as CH3 and then CH2. That should appear 2 times, and the COOH. If you have to draw this compound, guys, you simply have CH3, CH2, that should appear 2 times, and then a C with a double bond O and an OH, like this. Whenever you are given a condensed structure, all you have to do is to change into a structural formula and then write the IUPAC name. This is a carboxylic acid that has 4 carbons. That simply means my prefix will simply be butane, and then I just mix the prefix and the suffix. It will simply be butanoic acid. Are you together? That's how you move from a condensed formula to a structural formula, then writing down the IUPAC name. And then whenever you are given a molecular formula, the examiner needs to tell you that you are dealing with a carboxylic acid. Why? Because carboxylic acids and esters are isomers of one another. Are you together? Which simply means some of the compounds will simply have the same molecular formula. Are you together? So the examiner has to lead you that let's say you are dealing with C3H6 with O2. The examiner must tell you that you are dealing with a carboxylic acid. If it's a carboxylic acid and if it's given like that as a molecular formula, it's very, very easy to draw, because I know that my functional group will be at the terminal carbon. So I'll simply draw 3 carbons like this, and then the terminal carbon will simply have my functional group. If I can count there, I have 6 hydrogens, 3 carbons, and 2 oxygens. And the name of my organic compound, since it has 3 carbons, it will simply be propanoic acid. Are you together? Yes, I'll talk about isomers, guys, on the other videos, né? But please note that carboxylic and esters are always isomers of one another, always. Okay. Now let's just answer the following questions. Whenever I'm given a structural formula, guys, all I have to do is to write down the IUPAC name. Whenever I'm given the condensed structure, I must first change to structural formula and then write the IUPAC name. If I'm given an IUPAC name, all I have to do is to draw the structural formula. If I'm given a molecular formula of a carboxylic acid, I must draw the structure. And just write the IUPAC name. But I don't have to draw the structure because I know that my structure will be a straight chain. Yeah, my structure will be a straight chain. Okay, it's fine. Let's just answer the questions. Excuse me. Number 1, I'm given a carboxylic acid that has 3 carbons. Are you together? So since it has 3 carbons on its parent chain, it simply means that the prefix will simply be propan. And then all I have to do is to just join the prefix and the suffix. And then the full IUPAC name will simply be propanoic acid. This one has how many carbons? 1, 2, 3, 4, 5. It will simply be pentanoic acid. This one has 4 carbons. It will simply be butanoic acid. And then this one has how many carbons? 1, 2, 3, 4, 5, 6. This will be hexanoic acid. And then over here I only have 2 carbons on my parent chain. This will simply be ethanoic acid. And then my parent chain is like this. Please note that, guys, you'll never find a side chain at the terminal carbon. So your parent chain has how many carbons? 1, 2, 3, 4, 5, 6, 7. So this will simply be heptanoic acid. Okay, whenever I'm given a condensed structure, all I have to do is to draw the structural formula and write down the IUPAC name. Okay, for this one, I simply have CH3, CH2, and then COOH. So my structure has 3 carbons. That means I'm dealing with propanoic acid. Propanoic acid. Okay. Over here I have a CH3, and then I have CH2s that should appear 3 times because of that number over there. That's CH2 number 1, CH2 number 2, CH2 number 3, and then I have another CH2. Okay, I have another let me use one color, guys. I have another CH2, and then I have a C double bond O with an OH. All I have to do is to just draw the hydrogens as well. And how many carbons do we have? 1, 2, 3, 4, 5, 6. This is simply hexanoic acid. Okay. Over here I have my CH3, and then I should have the CH2s, which would appear 4 times. That's CH2 number 1, CH2 number 2, CH2 number 3, and CH2 number 4. And then after that, I'll simply have a carbon with double bond O and then OH. All I have to do is to write down the hydrogens. How many carbons do you have? 1, 2, 3, 4, 5, 6. We are dealing with hexanoic acid. Are you together? Please draw the structural formula for this one, guys. For this one, and then give me the IUPAC name on the comment section so that I can come back and check whether you're correct or not. Are you together? Draw the structural formula and then write down the IUPAC name on the comment section. Okay, now I'm given the IUPAC names. All I have to do is to just draw the structure. The structure of the structural formula for methanoic acid. Methane simply means I only have one carbon on my parent chain, so this will be simple. This will be the structure of methanoic acid. And then ethanoic acid. Ethane simply means I have 2 carbons. That's 1, 2. And then I'll have double bond O, H, with hydrogens over there. And then for pentanoic acid, pentane simply means I have 5 carbons. 1, 2, 3, 4, and 5. Then I have my double bond with an OH. Then I have my hydrogens over there. Heptanoic acid, I have 7 carbons on my parent chain. 1, 2, 3, 4, 5, 6, 7. Then all I have to do is to draw the hydrogens. You see, guys, whenever you're dealing with other homologous series, it's very simple, guys. The challenge would be on hydrocarbons as well as haloalkanes, because they try to trick you a lot. But for other homologous series, guys, it's just straightforward. It's just straightforward, né? Okay, if ever I'm given a molecular formula, I'm told that this is a carboxylic acid, I don't necessarily need to draw this, because I know that a carboxylic acid that has 5 carbons on its parent chain would simply be pentanoic acid. Pentanoic acid. But if you're not sure, you can draw your 5 carbons, and then at carbon number 5 you'll simply have a double bond O with your hydrogens. It's not necessary, guys, if you are given a molecular formula to draw, unless you were asked to do so. Are you together? And then over here you are dealing with the carboxylic acid that has 3 carbons. This will simply be propanoic acid. It has 3 carbons like this and double bond O with an OH. Just have to draw your hydrogens over there. Same thing applies here. You are dealing with the carboxylic acid that has 4 carbons. That's simply butanoic acid. 1, 2, 3, 4. You have double bond O. Oh my god, I'm drawing an aldehyde now. Like this. And then over here you have 6 carbons. 1, 2, 3, 1, 2. There was no need for you to draw, but you know that a carboxylic acid that has 6 carbon will be hexanoic acid. If you have 1 carbon on your carboxylic acid, the IUPAC name will simply be methanoic acid. If you have 2 carbons, that's ethanoic acid. 3 carbons, propanoic acid. 4, it's butanoic acid. Then you have pentanoic acid, hexanoic acid for 6 carbons, heptanoic acid for 7, for 8 is octanoic acid, and so on, guys. That's what, guys, that's what you need to know basically for carboxylic acids. Are you together? If you are dealing with carboxylic acids only, this is what you need to know. Please note that the functional group for carboxylic acid is always at the terminal carbon. Are you together? Is always at the terminal carbon. Please don't forget to answer this on the comment section. Firstly, you can just draw the structure on your book and then write down the IUPAC name on the comment section. Thank you for your time, guys. Just stay tuned for more videos. Thank you.